All right. Next talk is Christian, who's going to be talking about Docker on HPC clusters and HPC within Docker.
Yeah, my name is Christian. As Ken said, I worked for HPC systems like 8 years or so. Now I'm working for Gaikai, which is a Sony company. Not a bunch, but anyway, it's nice to tinker around with HPC still, and that's still my thing. So I have a big data problem myself, because it is like the topic could be like 4 hours talk, but I only have 20 minutes, so we better get going. I will just introduce the bits and pieces that I use. First, I use Docker, and Docker, as maybe a couple of you are familiar with Linux containers, they are a little bit different than traditional virtualization. Just to give a brief heads up, so in traditional virtualization we have a hypervisor, and on top of this hypervisor we have the same stack that we have beneath the hypervisor, so a kernel and a userland, and within the virtual machines, hence the name, you stamp up a complete virtual environment. You have your own virtual network card and so on. There are ways to improve it with para-virtualization and some nice tricks to do to make them more performant. But basically that's what it is, right? On the right-hand side we have like a little display about Linux containers. So in Linux containers environments you only have one kernel, so the host kernel is used even by the so-called, let's say, call them machines, containers, and they are only communicating with the host kernel, which has a nice advantage that the scheduling is only done by one kernel and not by the guest kernel with no way of knowing about other kernel or other machines that are running next to it. So that's kind of the thing. And when you want to use some cool technologies like InfiniBand, there are also some tricks, but basically what you could do is you can hand over the PCI device of the InfiniBand and attach it to a certain guest, and then the guest can use it as if he would have a physical slot in his machine. On the Linux containers, since you talk to the same kernel, you just have to load the InfiniBand module in the host kernel and the userland stuff in the container, and then you can use InfiniBand using containers, which is pretty surprisingly easy to set up. I tried it 5 minutes, and then I was surprised that I'm done after 5 minutes. So that was kind of nice. And since, oh no, there's supposed to be another. Anyway, sorry. Yeah, there's a slide missing, I guess. So the userlands are totally independent. So you could have a userland which is TinyCore Linux on the host. So Ubuntu Docker, for instance, uses TinyCore Linux. But you can have the userlands of the containers can be completely different. So you could have CentOS 6, CentOS 7, Ubuntu, what have you. So that's pretty nice. And you can trim down the userlands pretty neatly. I had a presentation 1 year ago or so where I benchmarked CentOS 7 as a host installation and a couple of other distributions as containers, and there it turns out that CentOS 6 was beating the crap out of CentOS 7 in certain benchmarks when they're using InfiniBand, because I used CentOS 7 alpha, so it was a bit unfair, but the container kicked the bare metal installation. That was kind of nice. And you can tweak and tune the userland of the container, and you don't have to care about the userland of the host. Anyway, but I said a quick bits and pieces, so I have to go on. So if we look at the Docker engine, so the Docker engine is the runtime of the container that is provided by Docker Inc. There are other container runtimes, but here we will focus on Docker engine. It creates, stops, starts, manipulates the containers, and all through a RESTful API, and it also handles the namespacing and C groups and all that. And a little bit about the networking part here. By default, the Docker engine will instantiate the Docker 0 bridge on your host, and when you spin up a container by default, you will get an IP address from this Docker bridge, which is a private host-only network, so to speak, if you want it in VirtualBox terms, and they have connectivity through this bridge, all the containers running on this system. You could also use the networking namespace of the server, so you get the same IP address, the same host name, and so on. And you could also start a container without any network. And what was introduced by Docker 1.9 was Docker networking, which is kind of nice. So you have the same Docker engine, or a different Docker engine. Now, from 1.9 on, it was called Docker engine. Before it was a Docker runtime anyway. You can have multiple servers, and they all have to have a key value store to synchronize the different engines. So now we have the Docker engines hooked up to console in my example. We have a console. It could be Keeper or SCD as well. And so they use VXLAN to create networks that span across complete hosts. So for instance, I could create a global network that spans across all nodes, and then I start containers on different nodes, and they will get the same, they will have the same networking address space, so the same subnet across all nodes. And I don't care where the nodes are or the containers are spun up. That's kind of neat. And I could have multiple of those, and they are distinct, so I could have a global and internal, what have you, and start different containers, connect them to different networks, and even connect them to multiple networks. So I could create nice environments for development, for instance, that every developer has his own network, and they don't have to fight against upon IP addresses or so on. That's kind of nice. So that's Docker networking. Docker Swarm is also some nice feature or some nice product to use in this stack. So when you have multiple nodes and you run a Docker engine on each of them, if you want to spin up a container, you have to connect to the Docker engine, then you spin up the container. If you want to start a container on a different node, then you have to change your environment variable again, connect to the Docker engine of the different host. And it's kind of a bummer because it's some overhead that you have to add. With Docker Swarm, you create a Swarm cluster, so it's called. So you start Swarm clients on each of the nodes, which are also containers. They connect to the Docker engine by mounting the socket of the Docker engine, so they can start and stop containers by themselves from within the container, which sounds scary, but it's not. And then you create, you spin up a Swarm master instance, and this Swarm master instance just proxies in front of all Docker engines and distributes the containers as it please. So there are multiple distribution mechanisms. It's bin pack, so it tries to put as much containers on one node as possible, and then you have one that distributes it evenly and so on, and you can create your own if you like to write your code. But I think it's not that hard. Anyway, but what it brings you is when for instance, I query one node and I do Docker info, which shows me the container, amount of container running, which is the memory available, and so on. And if I do this with the Docker engine directly, then I get this output. If I query the Docker Swarm master, then I got more CPUs, so all the CPUs in my cluster, and I got information about different nodes. And if I start a container with Docker run, then it will be magically placed on one node, which I can also pin. I can say, put this container on, for instance, Venus 007, and then it will be spun up on this node. So that's pretty neat. Okay, so this new technology is all nice and shiny, and if I do something new, I Dockerize it first. That's the first thing I do. I even Dockerized Scallion a couple of weeks ago. I haven't used it yet, but the image is there. And so I put in the Docker poll. And when I do this myself, I think, this is how it goes. I like, there are ponies and rainbows and so on. But when I talk to others, or to the ops guys of our system, so Guido, for instance, then he's like, oh, this guy again with his flamethrower and burns everything. So, and what's not helping as well is that there are so much buzzwords around Docker. So solutions and promise, production ready, enterprise ready anyway. And there's a lot of solutions for a lot of problems. I mean, Docker spends so much of the IT infrastructure that there are 50 answers for 5 questions, because it depends on where you look at it. If you look at development, production, or testing, or what have you. So that's kind of a broad field. So, and as I described traditional virtualization compared to containerization, if you talk to someone and say Docker, then he says, oh yeah, virtual machines, okay, I got it. So this you have to bring across. It's very hard at the beginning. So nowadays, maybe a lot of people heard about Linux containers, but 1 year ago it was impossible to talk to someone who knows virtual machines and to convince them that Docker is something different. And as I said, it spans a lot of environments. So what I try to do is spin everything up on my little laptop, but at the same time be able to spin it up on a workstation with more memory and more CPUs, or even on clusters, or even on big production environments. And what I want to do, I don't want to be a unicorn, or I don't need to be a unicorn. I don't want to have special distributions like CoreOS or RangerOS or what have you, because my opinion it's something that might be helpful in greenfield deployments and might be helpful if you want to have a very agile scaling approach. But I want to moreover leverage existing technologies and existing workflows, existing installations, and monitoring and logging of the infrastructure I want to put my Docker on. And yeah, the same for security infrastructure. So I want to reuse stuff that's already there and not put something completely new on. And I want to keep up with the upstream of the Docker ecosystem. I think that's very important because, for instance, 1.9 brought us networking and volumes. 1.10 will give us some username spacing and some IP configuration that you can tell the Docker run command just use this IP within the container, and then it will have this IP, which is pretty neat as well. And that's why I want to keep up with all the new cool features, and I don't want to rely on a vendor to provide a newer Docker version. And I think Atomicos is 1.8 currently, and they're not even updated to 1.9 without networking. But anyway, I don't want to brag about it too much. So what I want to do is, or what I did is reduce it to the max. I put Docker on an existing installation. The installation, I will show the configuration in a bit. I use Kickstart, or I do not even install it myself, so it was kickstarted, and I had an SSH access, and I used Ansible to install all the bits and pieces I need. And I don't want to focus on corner cases so much. I think that's a Docker Inc. approach anyway. They don't care about corner cases in first hand. And for instance, if you want to have multi-tenant IP usage, so InfiniBand usage in different containers on your host, then you are screwed because, yeah, there are also tricks to work around it, but there are a lot of snowflakey containers that you can create, but I think first I would like to get it going and then think about the corner cases later. And the same with user namespaces. I think there's also a need for doing something like this. But yeah, we'll get there eventually with a new version maybe. And then we have to play around with it first. And to play around with it, we have to be very flexible in using different tools. And that's what I'm trying to achieve here. And the HPC environment assumptions, I mean, that's a given, I guess. It's single tenant for me and focus on performance, so I don't care about security yet so much. Because I think, as said, Docker is so fast approaching or fast moving forward. When I think hard about it for half a year, then what I've thought about might be irrelevant anyway, so I not think about it yet so much. So the setup, I had 8 nodes from the HPC Advisory Council I had access to. It's like an old system, fairly old, 8 nodes with Xeons, 32 gigs, and QDR InfiniBand. As said, I use CentOS 7.2, which was updated from the previous mentioned 7 alpha. And to install all the dependencies in my stack, I use some Ansible playbooks. So I first install console as a service. Then the service starts. After the service is started, then the Docker engine can start because it has to hook into the console cluster as mentioned before. And so on. Okay, so how does it look like? I have these 8 nodes, as I said. The Docker engines are hooked to console as a key value store to synchronize over the networks that are created. I put Docker Swarm on top of it, so it looks like this. There's this Swarm clients that I talked about, and one master on one of the nodes. And they also use a key value store from console to synchronize. And then I just put a Swarm cluster in it, and I will show a link to the code and the playbooks and the compose files that I use, but since I have only 20 minutes, yeah, I will skip this. So I put Slurm cluster on 8 nodes, and since Slurm daemon itself it's pretty boring, I put some little benchmarking tool on top of the Slurm container to run really an application, an HPC application. And it could also pre-stage multiple containers of this sort, right? So this is what I've done a year ago. So I had an OpenFOAM container and an HPCG container and so on. And since when they are just sitting there and they do nothing, then they don't consume much resources. So that's why I pre-staged them. What could be also done could be that I have a Slurm daemon on the real hardware and that I just spin up the containers when I need to run a computation, for instance. This might be a little bit less resource hungry, but I think that since if the bash is just idling, it doesn't consume much resources, so I think it's no problem to have them all spin up at the same time. So this is basically the hello world of Slurm. I mean, Slurm is a resource scheduler, and it was mentioned a couple of times. So you have different partitions. I just have the stupid partition odd and even, which turns out to be like this. And since I use console, this is auto-generated. So if I would spin up 8 more containers, then the configuration of Slurm will be auto-generated out of templates, and then the daemons are restarted. And if I run a simple job, so I use srun minus n to have 8 nodes and just let them execute hostname. Then, and I executed on one of the nodes, then I got the output of hostname basically for all nodes. That's the Slurm cluster. And since we are not only an HPC dev room, but big data as well, I created a SAMSA container and put SAMSA on my cluster as well. So SAMSA, for all of you not familiar with it, it's a streaming processor, distributed streaming pipeline, which uses Kafka for communication. So you create a SAMSA job that reads from a Kafka topic and writes to Kafka topic. And so I had to stage Zookeeper and the Kafka cluster, that's our containers, on top of all the different nodes. And then I put a SAMSA instance next to it, and then I can run my jobs to the SAMSA nodes. I could set it up, or I will set it up with Yarn, so that I have a distributed the Yarn scheduler on top of it. But maybe I can even set it up with Slurm. 3 minutes? So Slurm, maybe? Yeah, out of time, so as you said, 3 minutes. I would like to have shown also Sensu, which is kind of a nice monitoring tool, which I don't have time. It's nice, look at it. Metrics, through Sensu, I collect metrics and I put them in Graphite environment, and I use Grafana dashboards to show cool stuff. Yeah, so recap. In my opinion, as I said, I will go with vanilla Docker tag because, and I can go with it on top of any distribution because I would like to keep up with the ecosystem and prevent a vendor or ecosystem lock-in. I think that's a pretty dangerous thing to do currently, but maybe I'm not earning money with it. So if you want to earn, anyway. No, and as said, I don't want to focus on corner cases. What I can achieve with 80% of the time, 80% or 20% of the time, then I will go for it. And I will corner cases are a thing for next year or so. And I don't want to scare away stakeholders. So Guido, as an ops guy and Gaikai, it should be simple, but not because he's a simple guy. It should reuse all our workflows and infrastructure, or HPC workflows and infrastructure. And it should be a solution in a probably literally it's a little buzzword here, I admit. Yeah, if you have questions, this upper link is a link to all the playbooks and hopefully no passwords and compose files and so on, and the vagrant file. On the my blog, I put a couple of blog posts about it, and I will continue to brag about it on my blog. And a little bit premature, but with the University of Pisa, we might have a little conference about this kind of HPC cluster setup. So we scheduled it in April. Maybe it's shifting, but hopefully it won't. So if you'd like to learn more about it, then yeah, ping me an email, talk to me, post a blog. So that's basically it. That's a good time.
We have time for a couple of questions.
The question was which storage backend or storage driver I use for Docker. Currently I use Docker OpenLayFS for a couple of distributions, but it's a little bit shaky. You have to patch the kernel, so if you can use our flash, I will recommend in the kernel is a little bit less. So or device mapper, but device mapper in some cases you have latency or it's a little bit slow. Overlay as should be a little bit, and I could talk about different layer stuff anyway. I think overlay could be
if you have several resources in the private clouds, why not distribute the loads across
the question is,
I answered the baseline.
no, you know. No, the question was why not use native installation or native virtual machines more than Docker?
No, just like, for example, if you have an OpenStack instance, if there's half a Docker container, instead of doing the approach of Docker having multiple containers, you just spawn off instances in the
No, it's an act. First, because I like Docker and I don't like OpenStack, I installed it 7 times, 7.5 times, and I finished it half the time, but I don't want to brag about OpenStack. But I think since you have with images, Docker images, you have clearly identifiers for the user land that you have packaged. This is a very nice way to reproduce your work. So if you have an input package and the ID of the Docker container or Docker image you use, then you can run the same workload with the same user land years after. So I think it's for reproducibility and for an academic approach, it's really nice. Maybe I didn't answer your question.
No, good.
If you want to have the answer from who runs the thing, like installing OpenStack is a nightmare, but in this it's like some
Just following on from that, you said that when you preload these things, it's a very small footprint. It's worth doing some work on that and actually saying what that footprint is, how many you could just have ready in your magazine to. I mean, how many do you think you can have ready?
I think there was a limit of 1,000 containers because of something.
So you could have a cluster with 1,000 applications ready to go?
Yeah, if it's just having slugd running, and if you use OurFest, then even the binary is loaded once to the memory. So anyway, but...
Well, how much is the footprint? Has anyone analysed it? Swaps out anyway, so...
No, it's handled by Turtle, I think it's so but I cannot say how much. It's just a group of processing.
It'd be fun to do 1,000.
Yeah?
That'd be fun.
You have a question?
Anyway, it's very kind.
Yeah, since if you use it, if you have multiple containers...
Nice to meet you, by the way. Cheers.
It's going to be Dockerized.
Yeah, it's nice. That guy knows what he's doing. It's really good. It seems you see a lot more prevalence of Docker on.
But he did an OpenFOAM Docker container.
Yeah.
But I mean, I don't know OpenFOAM that well, but it's crazy. You have to have the source code for GCC 4.7. You have to compile the GCC before you can compile the application. It's what are you guys doing?
That's funny. I mean, we maintain OpenFOAM in our center. We just sort of like, we're not going to build GCC. We're going to build it with our compiler, you know. But I think that's people. They've probably been burned so many times by not knowing what to do.
I used to use something, it was one of these visualization things, one of these commercial visualizations, and they actually shipped their own Python. There's a really out-of-date version of Python in there, because